Hello there and welcome to this course or summary course. My name is Valentine and I'll be your instructor. In this workshop or in this course, we are going to follow this structure. So we'll get started talking about the learning outcomes. After that, we'll talk about what the original program is, what it entails. That's the Moringa Data Science program. And why you'd want to learn those concepts that have been covered in that particular program. We'll also talk about just some comments. We'll provide our review as well as just our thoughts generally about what we think is afterwork about the program, what you can get from it, what are those shortcomings that it has. Then after that, we'll now go through a practice session where we'll take a crash course of those concepts that have been covered in that particular program. We won't cover all of them because they're quite broad, but also because of time. We just cover the most basic ones. So we'll cover generally I'd say about 75 to 80% of what will be covered. And yeah, so that's what we're going to cover. We'll provide explanations of what those concepts entail, as well as examples, code examples, as well as also challenges that you can be able to work on to just get a feel of those concepts and know whether you'd want to undertake that data science journey that you probably are thinking. And sometimes also some of the people that usually watch these courses are people who have some experience. Maybe they would want to quickly get a crash course on what's in the market and just to align themselves and make sure that they're not missing out something. So this workshop can also be a learning experience that will help you just solidify data science knowledge, more specifically pertaining to what will be covered in that particular program. That's the Moringa Data Science program. And then towards the end, we'll just talk about the next steps. What do you think? What do we think that should be the next step after going through this learning experience? So let's get started. So by the end of today, we are expected to have achieved these goals. We should be able to describe the core concepts covered in the Moringa Data Science program. We should be able to comprehend the benefits and limitations of the same program. We should also be able to engage in an in-depth learning experience, delving into core concepts covered in the program, based on the publicly shared course outline. So this is also a disclaimer. We do not have access to the detailed course outline. So what we are using to go through this summary course is basically what has been provided on the Moringa website. And also by the end of this workshop, of course, you should be able to basically undertake basic projects from the concepts or from the skills that you will have achieved. So starting off, the Moringa Data Science program, it's a course, it's a program by Moringa School. It's 25 weeks. And it comes in different formats, even though the course outline is the same. There's full-time online, where you get to go through the program online. There's full-time hybrid, where you get to go through part of the program online as well as in person. There's also the part-time program. So generally, you have those different modes of learning that you could undertake for 25 weeks. It means that also you need to, for the first two, you need to dedicate 25 weeks, so from Monday to Friday, 8 hours a day, as well as some other additional time to just complete the projects. But for the part-time bit, it's a bit longer than that. You could always just check from their website for that. But again, the content outline or the skills that you benefit or you get from this program will be still the same if you were to take any of those modes. The idea is that once you undertake the program, you undertake the program as a beginner in data science or beginner in data analytics, but they expect that you have some maths and statistics background. So you have maybe some college level understanding of generally statistics as well as mathematics. Maybe you've done calculus at some point, or probability, advanced probability, then that should be sufficient enough. Maybe if you did maybe statistics or even computer science, which of course in campus you tend to cover concepts in relation to maths and statistics and probability as well, then that should be good to go. That should be a prerequisite enough for you to be able to also join the program. You should also have some university education, so either ongoing or already have graduated. You need to be 18 years. And there's also an assessment test that you get to take before you join the program to just check on the understanding of some of the mentioned backgrounds, like, mathematics and statistics. It's usually called a diagnostic test that you need to undertake. Then you also need to be proficient in English, considering that the program is in English, both spoken and written. There'll be presentations, and you also need to have a computer. So it's also an investment in terms of time. So for 25 weeks, that is also something that you need to take into account, almost like 6 months. That's the cost, 1,740, and the learning outcomes, generally the learning outcomes can be summarized as, by the end of the entire program, you should be able to gain proficiency in Python for data science. That means you should be able to clean data, analyze, visualize, and perform machine learning. And you should also be able to develop some practical problem solving skills through just projects, mentorship, that will generally allow you to work on real world challenges in data science. So, that's just generally a bit of the program on overview in terms of the curriculum. The curriculum itself is not developed by Moringa, it's developed by Flatiron, which is a boot camp in the US. So Moringa has actually uses their curriculum from that side and delivers it into this market. And it covers the following modules. They call them phases. So they're not really as mentioned, but if you go to their website, you should be able to see that. You start with pre-work. So there's a bit of some Python programming fundamentals as well as data collection fundamentals that you get to go through. After that, you go through data analysis and engineering, a phase on that just equips you with basic data analysis tools. Then after that, you now moving into probability, scientific computing and quantitative methods. That's basic probability and statistics concepts. Then now you move into machine learning fundamentals, advanced machine learning. So, and in between, you'll find that there are breaks in between the 25 weeks. There are breaks where you do projects, and also you do soft skills. More details, again, you can find on the Moringa School website. The pre-work bit is not, it's technically, you do it before you join the program, so that by the time you're joining, you are expected to be already proficient in that. So generally, that is the structure of the program itself. Of course, we as Afterwork have our own views of what's happening here, and also probably what this program is strong in, and also what are its shortcomings, which we are now going to be discussing. And hopefully that should also give you a good idea of whether this program is good for you, or you could supplement it with other materials, or you could decide to do a different program, or just it provides transparency. So here we go. So our review. So the program itself, it covers fundamentals of data analytics and data science with Python in a comprehensive way. And it's in terms of the duration, we would think that it's a bit too long for a 6-month program. We think that maybe 12 months, considering that it's full time, you'd be expected to be there from Monday to generally Friday, spending 8 hours on the content, doing nothing else. Then we would expect that the program is a bit shorter, maybe 12 weeks, based on the content that's provided so far. we've delivered programs in even 8 weeks pertaining to machine learning, and that has worked. So that is something. It's a bit more stretched, maybe for really slow-paced learners. So if you really learn slowly, maybe that could be a help. But if you don't have time, then maybe rethinking about it. So, or rethinking of how you can go about it. But it's important to just have a good idea of that. The program itself has a big emphasis on machine learning. So if you might look at it technically, the pre-work is usually not part of what is counted. So from this particular, so you would start from the second bullet point so it's out of 1, 2, 3, 4. They're usually 5, but there's still 5. But now machine learning actually takes almost half of the entire learning experience. Actually, more than half. Actually, it's usually, I think it's 2/3. It should be 3 out of 5 phases. There are 5 phases in the program, but 3 out of 5, involve machine learning work, which sometimes, it's a bit questionable, considering that not all companies, especially for developing markets, are solving problems in relation to machine learning. A lot of them have collected data about their users. They haven't really reorganized it. So you'd expect a whole lot of maybe data engineering as well as data analysis. So it's geared towards machine learning. So the expectation is most likely that based on how it's designed, you're going to become a machine learning engineer. I'm not sure how many jobs there are within the market that this school delivers, but abroad maybe. But in terms of entry-level jobs, not sure. But again, the idea is that you should have a fair appreciation of machine learning after you finish the program. There's no a lot of work covering data engineering or storytelling. So data engineering involves collecting data from different sources, and many organizations store data in different data sources. Could be relational databases such as Postgres, MySQL, or other NoSQL databases such as MongoDB. Not much has been mentioned that will be covered pertaining to data engineering. So being able to collect data from those data sources and ensure it's in the right format for analysis. As well as also storytelling, because many organizations are still trying to understand the data that they are working with. One would expect the use of tools that communicate insights, such as dashboarding with Power BI and Tableau, but that hasn't really been covered. Our focus is really much on Python, but at the same time, also not so much details. There isn't so much details on visualization or creation of dashboards with Python, on emphasis of that. So one might also have a bit of some question about that. But again, that doesn't mean you shouldn't take the program. It just means you need to supplement that particular program with some other learning experiences. Like, at Afterwork, we have those dashboarding workshops that we have on our channel or on our platform. So that is also, a place where you could get those courses as well. It also lacks R. R is a popular programming tool that we normally use in data science, and many companies, especially in academia or companies involving themselves in research, undertake. So many teams in such setups normally use R because of the extensive ecosystem of packages and research packages, and it's important that as a data scientist you come out of that program ready to support other teams as maybe a junior entry data scientist. So yeah, it requires R, which again, you could always supplement it with other programs. And also something else, the idea that the program has been licensed from a US based bootcamp, it actually would imply that, the data sets or the context, the questions that you get are sort of westernized. So you wouldn't get Pan-African data sets. You couldn't get scenarios which are geared tailored towards the local market. So that is also something to keep in mind. But again, concepts usually remain the same when it comes to data science. However, the idea of having to work on problems that are more likely to be the ones that you're going to be solving in the market actually is a good idea, because it helps you to transfer the skills that you use, the technical skills that you use to the workplace after the program easily. So as an entry-level junior data scientist, which the program promises, that is something that you would need to take into account. But again, you could still supplement that with other learning experiences like afterworks, because we create a lot of content. But again, that is, it's not easy to find those tailored learning experiences, especially for different markets, but something also to keep in mind. All right, so that's it in terms of our review. So the next thing that we're going to be doing is now to go through the mentioned outline. We will go through pre-work, data analysis, then scientific computing, machine learning fundamentals, and a bit of advanced machine learning. We won't cover everything in each and every phase in the next 45 minutes or so, or 2 hours. So we will try as much as we can to just give you a snippet of what will be covered in that particular program. And if you feel like you're good to go, like it's a program that you would want to undertake, then well and good, you could always apply. Yeah, so let's do this. Let's get started. At this particular point, I'm going to ask you to visit the link that we've shared in the resources in the description section of this video. So you'll see a resources link, then there's a link there that takes you to the Afterwork website, and it's just below the stream or below this particular video in the description section, and it should take you to this page. And you can then just download or click on the sample resource, which will contain the content that we'll go through for this particular course. So click on that and it should get you to this particular notebook. So this is a notebook that we've curated. Let me even just zoom out so that you can see. This is a notebook that we have curated, which is just a document that data scientists use to share work. And it contains the content that will be covered in that particular program. Not everything, and it just covers generally what has been covered generally in that course outline. And something to note is that the content that we are providing, is not really affiliated with the owner of the course itself. The content belongs to Afterwork. We have curated and designed the content from scratch, in the hope that it's going to help people to just be able to navigate this space and be able, at the very end, just create change by just being able to apply those skills that they've learned into projects, and projects that could help their organizations or their communities. So yeah, once you get to this particular page, by the way, for those who are Afterwork members, you should be able to get to a practice notebook. You won't find the sample notebook, so you will find the practice notebook. For clarification, Afterwork members are those people who usually usually have a membership with Afterwork, and we provide them with all the resources that they need to get to learn how to wrangle data or how to become generally a data scientist. So they get extensive resources like the solutions to the challenges that will be covered. They also get extra challenges. So if you're going to be using the sample notebook, just note that you are likely to get like less than half of the challenges that members usually get. And you can always think about becoming an Afterwork member if that is something that you're really looking towards in terms of just becoming a data scientist or becoming a bit more serious about this journey. So yeah, once you have gotten to this page, so if you're an Afterwork member, you can use the practice notebook. If you're just here for just curiosity, then you can just use the sample. So I'll use the practice notebook and walk through with the Afterwork members. But of course, the practice notebook is just similar to the sample notebook, only that it has a few only that it has just generally more challenges. And again, you can always open the solution notebook for the other members. So yeah, so let's get started. So the first thing that you do once you get here, click on File, then Save a Copy in Drive. The very top, File, then Save a Copy in Drive. Let me zoom in a bit. And you can always rewind, pause the video, rewind if you feel like we are too fast. And we'll be moving too fast. Not too fast, we'll be moving a bit faster because of time constraints. All right, let's do this. So File, then Save a Copy in Drive. Then this notebook should open a new copy in a new tab that you can be able to make changes to and save. The document will be saved on your Google Drive. For me, I will open my notebook in playground mode. I don't want to make changes, and I also don't want to save a copy of the notebook. So this will just allow me, once I close this tab, everything will be lost. This is just for learning purposes. All right, once we've done that, connect this notebook to a new runtime. So what that does is just connects this notebook to Google servers, where you can be able to run the Python code that we are going to be working with. So click on that. Should take a few seconds to connect. Maybe 10 seconds. Sometimes it can even take just 2 seconds depending on where you're located. Yeah, so once it has connected, you'll see connected, a check icon, then it will disappear. Yeah, so we are good, we are connected. All right, let's start off with, we are going to go through 5 different sections, different phases in the program. So let's start with pre-work, Python programming. So let's expand that and we will start to learn about the basics of Python programming. So we'll move on quickly. So starting off, we'll start off with learning about variables and data types. So when it comes to working with programming languages, so when it comes to working on data science work, we normally use different tools to actualize the work that we want. You can work towards creating reports. That's data analysis reports. You can work towards creating dashboards. You can work towards creating scripts. Scripts are just programs that you create to perform a specific task, and they just help with automation. So in order to do all that work or to work on those deliverables, you need to work with just tools that help you to actualize those deliverables, whether they are reports, etc., etc. And one of the tools that we can work with is Python. Python is a programming language, and what it does, it allows you to create software. So programming languages are just those languages that allow you to create other software. And we are going to be using Python for just data analysis. You can't use, or data science. You can't use just any language. Well, you could use any language, but normally programming languages are designed to do specific kinds of work. There are programming languages for data science work, programming languages for creating web applications, programming languages for desktop applications, programming languages for dealing specifically with even a lot of data. So there's so many programming languages, but our focus will be using Python, and yeah, so that's what we're going to be learning about Python. Before getting started with Python, you need to learn fundamentals. So that's what we're going to be working with. Variables and data types, these are fundamentals, print statements, all these ones, there are 10 of them that we've highlighted here. Some of them are merged, some of them are not. So that's what we're going to be working towards. So let's get started learning about the first fundamentals. So when it comes to working with programming languages, we work with data. So data, we would need to store it in some sort of temporary container, like some sort of memory or just a container. Think of it as a temporary container. So if we have, let's say, the name Valentine, or the name Ruth, or the name of a city, Nairobi, then we can store that value, that's Nairobi, inside a temporary container. And that container, we would call it a variable. A variable is that temporary container that can hold one piece of information. So that's called a variable. And data comes in different forms. There's textual data. So like Nairobi is textual data. There is numerical data, but numerical data also comes in different forms. There's integers, there is decimals, etc. But in Python, for decimals, we call them floats. There's also a type of data called Boolean, where you can where usually has two values. It's either true or false. So that's also another type of data. But generally, just note that we tend to store data in variables so that we can later perform actions on them. Maybe if we stored the name Nairobi, it could be written in lowercase, including the N, Nairobi, in a variable called city. So city would be that temporary container. We can then later onwards in our program use the name city to perform maybe some operation on it. Maybe we want to capitalize city, the value of city. So we would capitalize city. We would just use the name city, but behind the scenes, the value of the temporary container, that city, would be converted into uppercase. So let's learn how to do that. Let's learn how to create variables. So here we have a variable called num, and we assign it the value 5 with equal sign. We also have the variable John. We assign it to the value name. So we use an equal sign to assign the variable. So what's on the left-hand side are variables. So here we have a number or an integer. Here we have John, which is generally, usually we call text data as string in programming. So we have these two variables. What you see here that has a hash, it's a comment. So behind the scenes, what executes Python code or Python programming code is usually a special program called an interpreter. So that's the program that we will give to this, we will give this code to, and it will interpret. It will run the code itself. So it won't run this first line because we have defined that this first line is just an explanation of the code that comes after, or it's a comment. But to define a comment, we usually use a hash. So hash, then the comment, then 5. Same case here. We have another comment. We have another comment, another comment. So code is what we have here. And then aside from just using just a variable, a variable can store one piece of information, but we can store multiple pieces of information. So we can store maybe instead of just one city, we can store 10 cities: Nairobi, Joburg, Mombasa, etc. Using what is called a list. A list is like a variable. It's also another type of temporary container, but can contain multiple items. But how we define the items that we want to store in a list, we usually use a square bracket. Then inside we have we separate the items that we want. And then once we do that, we can display what's hidden, what's stored in those variables using a print function, which you can see here. Print, then num, and we have these parentheses, the name, my list. So let's run this. If you see this pop up, just know that you had not saved a copy of this notebook in Drive, and you need to do that. All right, that's it. So we are printing. So if we do not run these lines, we won't be able to see what we had stored. So if I run this, the values have been stored. This has been stored in my list. John has been stored in name, and I5 has been stored in num. Already we've created 3 lists, but we have not, we haven't displayed them. So to display them or to print them, we use the print function, and we give a function an input, and it gives us an output. So this function called print, we give it num, and it gives us number 5 and name, and also my list, as you can see here. At this particular point, pause the video and work on the challenge. The next thing that we are going to learn, I think we've already even covered, these are just print statements. These are just ways of just printing out something. Like here, we printed out the values of the variable. Here, we can still print out a value that we would want. So we decide to print out this text, and we enclose it in quotes. By the way, text, we usually enclose it in single or double quotes. And we can also print multiple items. So we would give the print function multiple inputs, or instead of inputs, we usually use the term argument. So we have the name is, then comma, then another input. So to print these two, and we can also print that as well. At this particular point, pause the video, and then we can continue, and you can work on the challenge. And then once you're done, we can continue. If you're an Afterwork member, use the solution notebook to verify your challenge. So this is the challenge, by the way. All right, we can also now perform calculations on just even the variables that we have, or even just numbers. So we can use what are called arithmetic operators. So let's say, for example, we can say 10 plus 5 will be 15, and then we store the outcome of that in this variable, and then we print it out. We can do the same thing with minus, multiplication, division, as well as exponentiation to raise something to the power of something. So 10 raised to power 2. Then we print for each. There's another operator that gives us a remainder. Let's say, for example, if you wanted to get what's the remainder of 10 divided by 2, it's usually 0 because 10 divided by 2 is 5, remainder 0. But you can get the remainder by putting a percentage sign. It's usually called a modulus operator. So if you run that, you'll get the last as 0. If I find. But yeah, that's just for clarity because the challenge involves that. Type conversion. Sometimes we might have to convert maybe a piece of data that has been stored in a variable. Let's say a text that, some text can be, let's say number 12, 1, 2. We might decide to store that integer in the form of a string, or it has been stored by that in the form of a string originally. So if we wanted to convert maybe that string into a number, we can use now what are called also functions. There are also functions that allow us to do that. Let's say, for example, here we have 10, which has been stored as a string because of the quotes. We can convert that using the int. So you can see int function. So we pass num string and we print it out. We can also do the same thing. If this value is an integer, we can convert it to a float or a decimal point using a float function. And we can also convert a float to a string as shown here. And sometimes this has limitations. If you put maybe a letter, you won't be able to process that. You need some advanced tools for that. Pause the video and work on the challenge. So we've talked about variables. I had already mentioned lists, like you can store multiple items. So, once you have created a list, you can access an element or the item in the list by simply using what are called indices. So for example, we can print out the number, the list, the element in the list at position 2. So the elements inside the list usually have positions, but the first item is usually given a position 0. So 0, 1, 2. So we would give this to, we would say that the one that it is at position 2 would be 0, 1, 2. It would be 3. So here we would define as 3. So numbers, then square brackets 3 would give us now the element in the list. And you can play around with that to just see what happens. Alternatively, there's another type of, you can think of, I don't want to call it a variable, but it's a type of storage that allows us to also store more of data that we are working with. It's called a dictionary, and it allows us to create to add another dimension to the data that we have. Maybe there's some piece of information related to 1, the same case to 2, that we would also want to store together with now the other elements. Then we can do that. So we're using a dictionary. So a dictionary, we have we can have parentheses and curly braces. Are called curly braces. On the keyboard, you'll see them just next to letter P on your keyboard on the right. And then you define a key and value pair. So the key would be Alice, then the value that is related to that, Bob, then the value that's related to that. And you can also have, for the value, you can have a list, another list, you can have another dictionary, etc. So it becomes as complex as you'd want. Then to access the item, let's say the value of Alice, we just use still square brackets, but we use the key. So we want Bob, so we will get 22. So here we will get 3 and 22. Pause the video and then work on the challenge. Moving on, conditional statements. Sometimes you might want to check for whether the value in a variable or temporary container such as a list or a dictionary exists. Then we can use what is called a conditional statement or if statement. So we use it as shown. So first of all, we create a variable that we would want to check. It could also be a list or another collection, maybe a dictionary. Then we use an if statement. Then we have an if statement would also allow us to set maybe a condition that we want to check out the expression. So if x, this variable, is greater than 5, then we put a double colon to finish that particular expression. Then inside, there's usually an indent. So inside the body, so we have to indent it. This has been indented twice. You can do the once, but for twice it just helps with clarity. we would print, if this condition turns out to be true, we would print what's indented, and you can have multiple lines. You can have multiple lines, not just one line. Else, we print out what's here. And you can also have if statements inside if statements, etc. So in our case, x is equal to 10. So if x is greater than 5, which it is because it's equal to 10, then this will be printed, which is what's printed here. Pause the video and then work on the challenge. For loops, we can work on, sometimes we might want to iterate through maybe a list or a dictionary and perform some sort of operation. Then we can use a for loop for that. So to iterate to go through all the items. So for example, here we might want to go through this, then the items in numbers. So we say for 1, that's want. So we define a for loop by using the for keyword. Then we define a variable that will contain the current value during each iteration. So for the first iteration, it will contain 1. For the second one, it will contain 2, etc. Then we use an in keyword to then specify the collection that we want to go through, or the list or the dictionary that we want to go through, which is numbers. Then inside the for loop, just like in a if statement, there's a body statement. There's also a body statement for the for loop. Like in each loop, in each iteration, whatever that will be indented here will be run. So here we want to print out num. So in each iteration, we are going to print out num, which is 1, 2, 3, 4, 5. Pause the video and then work on the challenge, and you can verify the solution. Moving on, while loops almost work like for loops. The only thing is that for loops goes through every item, but for while loops, you have an expression. It's a bit more efficient. So sometimes you only want to go through the first 2 items. So you can put an expression with a while loop. So first of all, we define num, the variable first to start our iteration from. So we say while this expression is true, so while num is less than this variable, or less than or equal to 5, then we print out the body, which will be, we print this num, the current value of num, and then we also run this statement. This statement is also, this piece of line is also similar to this. It's num is equals to num plus 1. It's like that. It's only that we use what is called an increment operator to shorten how we write that. So let's run this, and you can play around, by the way, and see what happens. All right, pause the video, then work on the challenge. Lastly, functions. So functions, sometimes you might want to enclose our code that we have written so that we can use it somewhere else, and we can instead of writing the code from scratch, then we can enclose the code in a function and give that function a name, and then we call that function whenever we want. Let's say, for example, we want to, this is the code that we want, the one that I have highlighted. This is the code that we want to be running every time. So instead of writing this code again, and you can have hundreds of lines, we would still, instead enclose the code, or put the code inside a function, which we define def is the keyword for creating a function. Then greet is the function name, then the parentheses, which usually technically takes in inputs, but our function won't take inputs. And then inside the body, we define what we want. So to call this function, we just say greet, the name, parentheses, and we will be able to call it. All right, pause the video and then work on the challenge. Sometimes you might want to give inputs to a function. So instead of, and also get return values. So in our case, we might want maybe to have this function called calculate area of a circle. Then we have radius. This is the input. So what we might want to do is whenever we are calling the function, so this is where we are calling the function, by the way, calculate the area of a circle. We give this input, which is what is defined here, a radius, and then we, that radius, the value of the radius of variable will be applied inside the function, and we will return the value or the output of that function, or a value from the function, using now the return keyword. So we want to return area, and yeah, and you can define now maybe some other variables here. We pass it to 5, and yeah, that's what happens. Right. Pause the video and then work on the challenge. All right, now we are done with Python fundamentals. Now we are going to move on to data collection. So data collection just generally involves collecting data from data sources. This part we're only just going to cover how to import data from a CSV file, and we are going to use a library which called pandas, which is just code that has been written by other experts somewhere that we can reuse, and we can reuse its functions. So we're going to import it as PD, so give it a name or an alias as PD. Any instance that you see PD, we are going to be using pandas. So we're going to import pandas from this location using the read CSV file. So we give the read CSV this file, this function, and then we store it in df, and then we preview the data set. So once we store our data from a pandas, from this source using pandas, we would store it in this variable called df, but now in pandas we just call it a data frame, a pandas data frame, and then we can then apply other functions on top of it. Like here we're applying the head function to preview the data set. It will give us just the first five records, just for understanding. And you can also do tail to preview the last records, etc. All right, pause the video and then work on the challenge. All right, we're done with phase one. We should be done with phase one now, moving to phase two. Yeah, we're going to go through pandas and numpy quickly. Data cleaning. So when it comes to working with data, you need to clean it fast so that you ensure that the data is of quality and you can use it to make now reliable conclusions or recommendations. So starting off, you're going to load this data set, and please bear with us. We're going to load a lot of data sets just for diversification or diversity. It's not you're so just used to that. So once we've loaded our data set, you can check for missing values using the is null and some functions. So in our case over here, we're referencing the data frame and we're applying it is null as well as the sum functions. This is just going to just tell us what we are printing, the print statement. So that's where, by the way, print statements usually comes in. So yeah, so here we can see we have zero records with missing values. If we had records with missing values, you would have seen the columns. These are columns. It would tell us where exactly the missing values is in terms of the columns. How to remove rows with missing values? We just say df dot, we apply the drop NA function, and we can set in place to true to just ensure that the changes that we've made in terms of dropping the records with missing values has been applied to the original data frame. So instead of saying df to replace to apply this change, so instead of we can still rewrite it this way, but we can just have just one line instead of having the df in front. And here we can also replace incorrect values in the dosage column. Maybe in the dosage column we have 2 puffs as needed, so we just say just 2 puffs. So maybe you might have other instances. You'd have to investigate further for that. And then we check for missing values, etc. So here it's just a quick data cleaning, and we have a whole data cleaning course on Afterwork, which you can always check. Actually, several courses on that. Pause the video and then work on the challenge. Sometimes you might want to select columns. So in order to just work on a subset of data set, maybe you have hundreds of columns, you just want maybe 3. So how do we do that? Let's load this data set, and then we select the specific columns. So we use df to reference the data frame name, and then square brackets, then we pass it a list of items which correspond to the names of the columns that we want. So we want name, age, and diagnosis. Name, age, and diagnosis. We don't want these other ones. And we store that in this new variable called selected columns, which is still a data frame. And then we can apply still those pandas functions like head to preview the data set, the new one. All right, pause the video and then work on the challenge. We can also filter for records. So here we just technically we filtered for columns. But here we can filter for records to just ensure that we are working with, again, another subset of data. Maybe if you have a data set that covers, that talks about maybe all countries in the world and you only want to focus on one, maybe Kenya, or maybe Africa only, if there's a column called continents, then you can do that. Let's load this data set, and then we apply a function, we apply a condition to perform filtering. So we create this condition, we use df square brackets, then we specify that we want to use age column. So df age, this is how you can select the values of this column, by the way, where values is greater than, so df where it's greater than 40, then that's what we want to select and store that inside filter df, and we display that. If you have more questions about filtering, please check out the filtering course that we have. All right, pause the video and then work on the challenge. We can also perform sorting. So we can decide to also sort this final data frame, maybe based on income, etc. And that's what we're going to learn. So let's now load a new data set. Can try and understand it after previewing it. Then we can, let's say in our case here, we want to sort the records in this data frame df by age. So we want, records with smaller ages first, then larger ages later. So yeah, so we can do that using the sort values function, and then we pass it, we give to it, we set the parameter. So functions usually have parameters, which is what we are setting here. So by parameter, we set it to have age. So we want to say that we want to sort the data from df by age, and then we say ascending to true to false, to be able to, actually this is in descending order, sorry. So we can sort, when we say ascending is equals to false, we're actually going to descend it to arrange the records in descending order. But if it's true, it will be in ascending order. But this is descending order when we set it to false, this parameter to false. So you'll see that we have 70, 65, 60, so the ages are coming down. Pause the video and then work on the challenge. Moving on, we can also perform what is called grouping in order to get a subset or to create a summary table from a larger table. So if we have a larger table like this one, let's say, for example, this one that you see here, and only what we want is we want maybe a smaller table of gender and age and average age for the entire date table. So this is a summary table of the larger table. Then we can use a group by. So it's like creating just pivot tables. So we use a group by, we use still the data frame that we have created here. Then we apply a group by function, and we specify the column that we want on the left inside the group by parentheses. Then we apply now, we specify that we want to use the age column for the other columns, column that will be on the right, and we specify the function that we want to apply. We want the mean of age. We can also specify maybe but it may not make sense in this case, but you could also have mean, max, etc. All right, pause the video and then work on the challenge. Moving on, so we've covered how to work with pandas, which we can use for data manipulation. Now we're going to work with numpy, which you can use to perform scientific computation. So this also allows us just to work with data efficiently. So if, as a data engineer, you might want to work with this work with this. So, and when we're working with numpy, we work with now not lists or those other, we work still with variables, but we don't work with lists. We usually work with another type of storage type of variable, but we don't call it variables, we call them data structures. They allow us to store data efficiently. So we're going to be working with what are called numpy arrays. So here we can decide to store, this is a list, but we want to create a numpy array out of this list. We use the np.array or the array function for that, and we store the final arrays inside this particular variables and print them out, which we have here. These are numpy arrays. Or alternatively, we can also store a numpy array. You can create a numpy array from a data set as shown. So here we use the numpy array. We don't use pandas, and we use the generate from text function. So it gets this data set. Then we specify what separates the columns within the data set. We also specify that the data type that we have in the data set, and we also specify encoding, which is a way of storing textual data. So normally UTF-8 is usually the standard. So this is what we have, and we can perform other operations on it. So we can decide to access maybe array elements. We might maybe decide to, let's say, let me load this other one. So by the way, you can pause the video and work on this challenge 2.1. Once you're done, we can continue accessing now array elements. Let's see how we can be able to do that. So once we have loaded our data set, which is this one, we can access, say, the price column is you can just still just use the position. Let's say the first you can use indexes. So you can use so the first column usually has index 0, the second one 1, 2, 3, 4. So the price is on position 0 or position 2, so it's 0, 1, 2. So we can be able to access its elements as shown. The same case with quantity for position 3, the same case with sales position 4. Right, pause the video and then work on the challenge. Boolean indexing, we can also apply conditions still from on what we have. So let's say, for example, let's load this data set. So for example, we wanted to just focus generally on, and you'll note, by the way, that something that we've done here, we are specifying that we want to have names as true, but here we don't have names. We haven't specified it. It's usually false. And when you look at this, you'll see the output is slightly different. But here we are specifying the names to be true so that we can work with the names. So once we've loaded the data set and previewed it, we can then decide to create what is called a Boolean array and specify that we want to get values for income column. So data square brackets income greater than 6,000, and that's the condition. And we pass the condition, which is a Boolean array, to data, and then we, I did not run that, and then we display that, and we can get our records. Pause the video and then work on the challenge. We can also work towards having aggregate functions. So we can work with aggregate functions as well. So, calculate efficiently our data. It just helps with numpy. If you use this approach, you're able to use lesser resources. But again, not many organizations are using so much to the extent that they cannot afford. But for optimization purposes, sometimes you might want to use this approach. Instead of using pandas, you use numpy. So once we have loaded our data set, NaN would refer to textual data that you have in your array. What we might want to do in our case, by the way, you'll note that we have now, instead of saying the data type to be none, we have specified it, we want it to be float, so that we can be able to perform mathematical operations. So we use, let's say, np sum function, and then we specify the column that we want to work with. The same case with price, etc. Pause the video and then work on the challenge. All right, I'll just go through quickly the rest of the sections. Moving on, phase 3, scientific computing and quantitative methods. So sometimes we would want to learn about machine learning, which involves creating these special programs called models that behind the scenes technically use probability concepts and statistics. So that's why probably, you need to first go through that. That's why they have structured it this way. So here we just are going to talk about just quickly probability, where it just refers to the likelihood of an event occurring. So if you have a probability values usually range from 0 to 1. So, if you have a higher probability, if it's 0.8, it means that the probability of that event occurring is high. So in our case, we can calculate maybe the probability of getting heads given this particular sample space, which is just 1 out of 2, because there are 2 outcomes that we can get. For heads, it's 1 out of 2, and then we can calculate the probability by, say, if we wanted to get heads, it's usually favorable outcomes, 1 out of 2, and which is 0.5. Pause the video and then work on the challenges. So there's descriptive statistics. Now we will move back into a bit of some of what we were working with, pandas. So sometimes you might want to just get some statistics numbers from the data set that we work, like what's the mean of a particular column. Then we can use the describe function. So this is one that we can use. You can print it as shown, or you don't even need a print statement, and you just apply it and it will give you the columns, the numerical columns, and the statistical details, a summary statistical details about those columns, like the mean of price is that, quantity is that, the count of the values. Sometimes if you get 9 somewhere here, you know that you have missing values. Pause the video and work on the challenge. Central tendency measures. So sometimes you might want to calculate mean, median, mode. So if it's not covered here, like mode, we can do that. Let's say we calculate the mean of sales amount or the median of that. We use a median function for median, and mode, and specify square bracket 0 to specify the item that occurs most in that column, and then we can print them out as such. Pause the video and work on the challenge. We can also calculate variability measures, which are which measure the spread of or dispersion of data in a data set. So we can, let's say something like standard deviation, mean, also the range. We can also do the same thing. Yeah, let's do that. Pause the video and then work on the challenge. Sampling methods, we can also get a random sample. So if you have 100 records, you might want to get just a random sample of 10 records. Then we can use the sample method. We can specify it as shown. Using the sample function, we set the parameter of n to 3 and random state to ensure that every time we run this code, we get the same records, but which have been selected randomly. So if you run this again, you'll still get 3, 16, and 6. But if you remove random state, you would get different records each time. Pause the video and work on the challenge. Sometimes you might want to create histograms, box plots to just understand our data further. So we would work with matplotlib or seaborn. So let's run that. Let's just create a histogram. So this is a data set that we have. Histogram would just give us an idea of the distribution of data. It has one column. So to create a histogram using seaborn, SNS, which is here, we can use histplot, then we pass the column name, and then we add a title to the plot. We use matplotlib for those other details, and we display it. There's our histogram, and we can also do the same with a box plot to just get an idea of also the distribution. We've covered this also in another workshop, so you can always feel free to check that out. All right, you can pause the video and work on the challenge. Linear regression, you can always go through linear regression. It's a technique that we can use also to create models. It's usually the basic technique. When it comes to creation of machine learning models, there are usually different steps. You first of all import the data that you want to work with, prepare that data. We haven't prepared it extensively. Then you import just different tools that you're going to need. Let's say this is linear regression. It will allow us to create the linear regression model. This function will allow us to split our data set, the one that we're going to train the linear regression model on. And this will allow us, mean square error will allow us to calculate the accuracy or the performance of the actual model. So if we run this, technically, by the way, let me run this to load the data sets that we're working with. It's a large data set, and we would need to extensively do some other details, but we've only just defined 2 variables here for just ease of learning. And this is the root mean square error that we get, which is small. Normally, when we work with a data set, a smaller data set or when we work with models, especially what are called regression models, which predict a numerical variable, then we would work with a type of evaluation metric called root mean square error, and we determine that a model is accurate is if it has like really little in terms of a root mean square error. If it's small towards 0. So if it's closer to 0, then we say that the model performs well. And then we can use it to make just predictions as shown. Now, at this particular point, there are a few other sections that we haven't covered. That's module 4, that's phase 4 and 5. I'm going to ask you to just take time to just go through this notebook by yourself, because we may not be able to go through the entire notebook altogether. We've provided some self-explanatory notes that should give you a good idea of how you can be able to cover these particular concepts. Like regression and classification generally involves creation of machine learning models. For regression, you would be predicting a variable that is numerical in nature, like sales. But for classification, you'd be predicting a variable that is of categorical nature. Like in our case, we would be predicting something like heart disease. whether someone will have heart disease or not. So take time to go through that, as well as advanced machine learning. Again, there's already self-explanatory content on that, dimensionality reduction, and also PySpark, which is a tool that allows us to work with large data. If you have any questions, feel free to ask in the chat. And if you'd want to explore some of these topics a bit more in depth, feel free to visit some of the courses that we have on Afterwork on the YouTube channel. We've explained them extensively. All the best in your learning journey, and see you in the next video. Give this